Okay, friends, let's do one of these net ionic types of equations. These are pretty simple. The rules are that if you see something that is aqueous, that means that when you put it into solution, you split up those into the ions, not into the atoms, as a lot of people try to do, but into the ions. So let's quickly identify the ions. I have silver, that's an ion. I have nitrate, NO3. You don't split that up into the N and the O. I have the ammonium. I have the carbonate. This is a solid, so it's not an ionic compound. And then I have the ammonium and the nitrate over here. All right, the way I do it is I write the complete ionic equation, and then I cancel out those things that are the same on both sides, that aren't doing anything. We call those spectators. They're just watching. They're not doing any chemistry, actually. Okay, so anything that says aqueous, we split up. So I have 2 Ag, it's a +1 charge. You should know that. Plus 2 NO3 minus. That 2 is distributed to both of those. Plus the 2 ammoniums plus the carbonate ion, it's a +1, plus the carbonate, 2 minus. And that's going to yield Ag2CO3. You do not split that up because it is a solid. Plus 2 ammoniums plus 2 nitrates. This is the complete ionic equation. All right, the next thing I do is I cross out those things that are just the same on both sides that aren't doing anything. So I do have 2 NO3s on both sides that don't do anything. I have 2 NH4 pluses that don't do anything. And that's it, everything else I need to include. So now I write the net ionic equation, which gives me 2Ag plus, it is aqueous, plus CO3, 2 minus, which is aqueous, and that's going to yield Ag2CO3, which is a solid. This is the net ionic equation. This is the chemistry that's actually going on. Those other ions that are in there are just watching. They're not doing anything. They're spectators. So what's the step? Where do people get this wrong? They get this wrong when they break these up into the ions. A polyatomic ion is an ion, so you keep that NO3 together. Make sure you get your charges right. Okay, this carbonate's a 2 minus. We should have that memorized by now. That's just the way that it is. Same with the ammonium. We should know that that's a +1 charge. These are very common in the laboratory. So write the complete ionic equation and then cross things out that are the same. That'll get you your net ionic equation, and make sure you include your phases and your charges in these. Way, way, way doable. If you don't know your polyatomic ions, though, you might be in trouble.